Welcome back, my fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Now, I shouldn't be breaking any news to anyone when I say that taking shortcuts in life can lead to negative consequences such as compromising quality and missing out on valuable learning experiences or just experiences in general. And it has become more and more apparent, as I'm sure most of you are well aware at this point, that with the rise of general artificial intelligence, or as the cool kids say, Gen AI, that whole taking shortcuts thing has become easier than ever. And that is especially true for software development and the broader software development industry, or I guess software production, software engineering, whatever you want to call it. The creation of software has been inundated with this whole general artificial intelligence stuff. So from cheating on code interviews to producing flaming hot piles of garbage just functional enough to make a quick buck on, the use of AI to cheat your way through being a software developer is definitely at an all-time high, and I think it is about time that we address it in this episode. So that is coming up, but before we get into that, let's start with our trivia question for the week. So this week's trivia question is the IEEE 802.11 is a family of standards that make up Wi-Fi, the first iteration of which had a max blistering speed of 2 megabits per second and was released in what year? So what year was the first iteration of Wi-Fi released? And that is your trivia question for the week. Now, before we get into our cybersecurity tip this week, I want to harken back to a previous cybersecurity tip we had a couple weeks ago, where we talked about how you should be using end-to-end encryption messaging apps for all of your messaging where possible. Now, I wish I could take credit with that cybersecurity tip for the spike in the number of downloads that Signal saw this week, but alas, I don't believe that I can. Now, according to TechCrunch, Signal downloads on iOS and the Google Play Store were up 28% on Monday, and from the daily average over the past 30 days, and that's coming from App Figures, I guess is where they got their numbers from, and downloads in the US were up 45%. Now, obviously, my episode where we talked about the how that cybersecurity tip did not air last week, and it by no means saw a massive spike in viewership on Monday. So, unfortunately, I was not the reason why Signal saw a mass amount of downloads. But if you're in the US, you're probably already well aware of why Signal might have seen a massive amount of downloads. And if you're not aware, suffice it to say, The Atlantic published an article this week, I guess on Monday, where the author detailed how he was, I guess, accidentally included in a Signal group chat with some high-ranking United States government officials. Now, I guess if you can take any silver lining from this, at least they were using an end-to-end encrypted messaging service, so I guess props to them, and not just sending all their messages in just, plain text SMS. But that's about as far down this rabbit hole that I'm going to go, because I am not going to touch this with a 10-foot pole. But I figured since Signal is, a very common end-to-end encrypted messaging platform, and that kind of sort of falls in the purview of this podcast, I figure it was at least mentioning from a very surface level. And also because we've talked about Signal in the past, so I just kind of figured it was worth mentioning. But that's all we're going to talk about it. So if you're interested in learning more, you can go ahead and do your own research. But with that, let's get into this week's cybersecurity tip. So I'm going to probably sound like a hipster for saying this, but this week's cybersecurity tip is to not use mainstream apps. Or if you do use mainstream apps, at least make sure your apps are up to date. And the reason I bring all this up is I saw an article, which I'll have linked down in the show notes, titled Top 3 Microsoft Exploits Hackers Use in 2025. And if you don't use Microsoft Office, you don't have to worry about any of these. So Microsoft Office, without a doubt, is the most mainstream solution for things like, spreadsheets, word processing. Heck, we literally use the term PowerPoint for any kind of slideshow presentation, regardless if it's actually PowerPoint or not. Microsoft, without a doubt, is the king when it comes to your generic Office suite of tools. But what I found hilarious about this was one of the exploits that's being used is the Felina exploit, which we covered this back when it first came out, which I believe was like 2.5 years ago. And, it never ceases to amaze me how exploits, in the case of Felina, are, remote code execution vulnerabilities. And these vulnerabilities somehow remain unpatched for years. How an exploit like Felina is still being exploited in the wild, basically 2.5 years since it came out, is mind-boggling. Which I don't care, which company or which organization you work for. If, as annoying as it is, your company or organization should be pushing mandatory updates to your device, or otherwise, if you don't update, basically quarantining your device, basically not allowing it on the network because of things like this. I just don't understand how you can go over 2.5 years and not update Microsoft Word. It's not like it's a server that needs to be on 24/7 in order for you to make money. You can take, the couple minutes it takes to shut down Word and run the update. It's not that complicated. But even with servers that have to be up 24/7, there's this thing called live patching that exists, which allows you to update your servers and update the kernel versions without necessarily having to shut them down. So there's really no excuse for not being up to date on your software updates. Now, while it might sound like I'm blaming the victim here, I'm not, because at the end of the day, you're not the one that committed the crime. You're the one that had the crime committed against you. So obviously, it's the threat actor's fault for hacking you in the first place. Now, if you're thinking there's a but coming here, you are absolutely correct, because the but is, if you're using software that hasn't been updated in 2.5 years, I'm not sure what you want me to tell you. If you want me to sit here and console you and be like, I'm sorry you got hacked, like I said, it's not your fault you got hacked, but at the same time, you're basically looking like an oasis in a desert, and the hacker hasn't had a drink in a couple of days, is basically what I'm saying. It's not your fault the hacker came to you, but at the same time, you kind of made yourself look like a juicy target. Again, it's not your fault you got hacked, because it's, again, the threat actor that did the hacking, but at the same time, you weren't exactly doing yourself any favors. So, Yeah, so and it's not just, the Microsoft Office suite and Felina that's being exploited. I've heard stories of Log4j still being exploited in the wild. And Log4j, that was almost 4 years ago. So if you're still using a vulnerable version of Log4j, I really don't know what to tell you, because if you're somehow assuming the best case scenario for you is your piece of software is just so critical that it can't be down at all and it needs and relies on Log4j in order to function, all I have to say is you've had basically 4 years to update your app and come up with a solution that either uses a newer version of Log4j that doesn't have the vulnerability or uses a different solution and push the update to production. Like, I don't know what you want me to tell you. Like, if you're this bad at updating your software, I just don't. I think I probably should just stop here, because at this point, I think it sounds like I'm just blaming victims at this point, which I think that. But the reason why I bring up the whole point of not using mainstream software is simply this. The reason why, as we've touched on before, the reason why Windows is such a prime target for hackers is not because it's less secure than an operating system like Mac OS or Linux. The reason why Windows is targeted more is because Windows is a juicier target. If you look at the market share, Windows is far and above the most dominant operating system when it comes to desktop platforms. So if you're a threat actor, of course you want to target the most, the largest pool of people to have the highest chance of getting a success. Because it's basically just a numbers game. So we take Microsoft Word, for instance. Microsoft Word has somewhere in the neighborhood of 750 million users. So let's say that you're trying to run the Felina exploit, for instance, and the probability of that working is 0.001%. If you're still targeting every single Microsoft Word user, you're still in the ballpark around of hacking 10,000 people, which is still a ton of people to hack. If you're a threat actor, like 10,000 people is a large number of people, and potentially, depending on where these people exist, depending on what companies they work for, you potentially could be looking at decent paydays if any one of those 10,000 end up, panning out for you. So this is why threat actors tend to go after the juicy targets, the ones with the largest user base. So it's not because the less used apps are more secure, it's just there's a smaller user base, so the likelihood of this 0.001% panning out is significantly smaller than, say, the 750 million users or so. So I guess to summarize here, there's also a difference between using an app that hasn't had an update in 2.5 years versus an app like, say, Word that has updates. I don't know how often Word updates, like monthly, bi-weekly. I don't know how often Word updates. I basically don't use it. But I know the updates are fairly recurring, like they come out, fairly regularly. So it's not like you're using some open source app where the developer kind of got the app to where he thought it was good and he didn't want to add any more features to it, so he just kind of let it sit there and it hasn't been touched for a couple of years. This is not what we're talking about. Now, if you're using that app where the developer hasn't touched it in 2 years and you get hacked, that's one thing. Like, you were up to date on all your updates and, 0 days are a thing. But if you're intentionally not being up to date on your software updates, you're basically just, putting a, kick me, sign on the back of you, and you wonder why people are kicking you is essentially what's going on. Now, of course, like in this kicking example, the person doing the kicking still has to be the active one to do it, but you're also kind of inviting them in doing that as well. So yes, Either don't use mainstream apps to at least reduce your risk of being a target, or just do what you should be doing and keep your apps up to date. And that is your cybersecurity tip for the week. Now, moving into what nerdy stuff have I been up to this week? So this week, I didn't expect to get up to the nerdy things that I got up to. So I was playing around with my Elite encryption algorithm this week, specifically the Swift version, and I noticed some rather peculiar things. So first off, I guess when I was first developing the Swift version, Swift 6.0 was still, I think, kind of in this, I don't know if development phase, I don't know if the 6.0 had officially been released or not, or if it was still kind of in a development phase. I don't remember, but their numbering scheme, I believe, has changed. Because I remember when I was originally creating the Swift version, I had to use 600.0.0 for it to work. But now that would basically just throw an error and be like, this doesn't exist, essentially. And they changed it to be, I guess, 6.0.0. But the other thing that was peculiar was there must have been some kind of updates they did, because the Swift testing framework that I was trying to include basically is unnecessary because it comes included with Swift 6 and greater. So I basically removed that. That kind of fixed some things. But then I also noticed some issues with concurrency. So one thing that my Swift version have, so I guess to backpedal, we touched on this when I was going through the development process for creating the Swift implementation of the encryption algorithm. But as kind of a quick recap, Swift doesn't use threads for its concurrency. So if you're coming from say a C, a C++, a Python, a Java kind of a background, if you want to do things concurrently, that is, run multiple tasks within your program at the same time, you would implement a threading model, or basically you would spin off multiple threads to run different tasks at the same time. And threading is kind of its own beast. At least in my educational background, threading was basically an afterthought and wasn't touched on and covered very well. But it is something that if you want to become a good software engineer and software developer, it's something that you definitely need to know and be able to take advantage of. But with that being said, Swift uses a different model for its concurrency. So they basically just kind of do everything on it's a bunch of async and await type calls, and you can kind of make things like queues and whatnot in order to do your concurrency. Basically, you're not spinning up threads and doing mutex locks and things like that is basically what I'm getting at. There's a couple other languages that do this too. I think Go routines are kind of a similar type of a concept, where basically you're not actually spinning up individual threads to do your concurrency. But anyway, the point being is apparently that concurrency, I guess, framework or whatever in Swift only existed in version 5.5 and later. And some of the Macs that I was trying to get my encryption algorithm to build on had older versions of Swift than that. Evidently, Big Sur and macOS Catalina run Swift versions 5.4 and 5.3 respectively, which I guess in fairness, those were from, I think, like 2019 and I want to say 2020 were the years those came out. So, I mean, we're getting to like, the 4 or 5 year mark for those, 4 for Big Sur and 5 for Catalina. So they've kind of been around a while. But I wanted my encryption algorithm to natively build on those platforms. So I basically kind of had to rework some things, modified the package.swift file and basically just added compiler checks throughout the code base. But the really, I guess, kind of annoying thing about Swift's concurrency model is the concurrency and the async functions are viral. And essentially what that means is if you make an async function to basically run, concurrently, run multiple tasks concurrently, any function that calls that async function thereby has to be an async function. So depending on how deep down you create this one async function, that basically spreads all the way up the chain, and it can kind of be a nightmare. Thankfully, my program is small enough, and the number of async functions was contained enough where I basically only had to change one file, technically two if you count the main function. But for the most part, it was basically contained. And the other annoying thing, which kind of annoyed me even more, was how Swift does its if checks. So me coming from a kind of a C and C++ background, if defs are a wonderful thing. So if defs are basically, compiler checks where the compiler will, do some checks to see if these conditions are true or not, and basically determine if this code should actually be included or not. Swift, on the other hand, has this, but it's not as, I guess, robust. So basically what I was trying to do was put the if check for the compiler just around the function declaration. So basically, function encrypt multiple files or something like that, for example. I don't think that's actually the name of the function, but you get the point. And then at the end, it would have, an async. So basically, the point was to put an if check around that, and then basically just have to modify that, so I don't really have to basically rewrite the function twice, essentially. But Swift apparently doesn't allow you to do this. It kept throwing errors that I had an extra curly brace because for whatever reason I don't know why it was doing that. So basically I had to end up writing the functions twice anyway, which was kind of annoying. Thankfully it was basically just a copy and paste job. Now there were a couple places where I was able to just do an if check around a specific variable declaration, which was nice. I didn't have to do a ton of duplicate work, but yeah, so not entirely sure why that's a thing, but it is. Now, I could, in theory, have broken up those functions even more to make them even more modular, so I wouldn't have to have basically had to rewrite the code twice. But the problem is those async functions that called and did the awaits and everything and the concurrency were very intertwined with the code within the function, things like local variables and things like that, prompts, that kind of a thing. So trying to abstract that out and then also pass that back in, it wouldn't have been impossible, but it just kind of would have been annoying, I think. The long-term solution, it probably would have been better to even abstract it even more, but I didn't feel like doing that. Don't be like me, I guess. But anyway, the point of this being was I did inevitably get it working, so basically, the only difference if you're using a Swift version older than 5.5 is you don't get the prompt if you're either encrypting or decrypting a directory if you want to multi-thread it, essentially, which, to be honest, at least in my use case, not really that big of a deal. And also, you're probably... I haven't really granted, the files that I was always testing on weren't massive files where, actually multi-threading would make a difference. But in theory, if you were, to try to, encrypt a photos directory or a video directory or something like that, then of course multi-threading and concurrency would definitely speed up the process because those files are significantly larger than, say, a couple of text files or maybe some source code files that are, a few hundred kilobytes maybe in size tops. But that's basically the only difference. It compiles, it works now, it's natively supported, so I was definitely happy to get that working. So that is real software development, but let's talk about some not real software development and cheating to get your way to the top. Now, the first story I want to kind of talk about is one that has actually been out for a while. It's been out for almost a month at this point. And this is basically a story of FAANG getting pwned. And if you're not familiar with what FAANG is basically the kind of, at this point, it's basically a catch-all term to basically cover big tech or any of the big companies that really deal with software development. So originally, FAANG was Facebook, Amazon, Apple, Netflix, and Google. But now you can also throw in, companies like Microsoft, throw in, what are some other companies? Oracle, basically any of the big name companies that really deal with and writing software. They kind of get lumped into this FAANG name. So FAANG has been basically kind of turned into a catch-all. But basically how the story goes is there's this kid from Columbia University, or I guess I should say formerly from Columbia University, because Columbia kicked the kid out for actions he did in his free time, which is a little interesting, but all right. So essentially what this kid did was he built an AI tool, which he called Interview Coder. And essentially what this tool would allow the user to do is to ace, I guess in quotes there, ace technical interviews for software development jobs where the interviewer would basically be none the wiser that the interviewee was using basically an AI system to basically cheat on the interview. So in a nutshell, how this tool works is it would take screen grabs of like the question and the prompt and things like this, ship it off to ChatGPT, and then it would basically tell you what you should be saying and what code to actually put in for your answer, and basically telling you what to type. And for the uninitiated, the whole idea of the quote-unquote technical interview was basically a brainchild or popularized by these FAANG companies. And in essence, what these technical interviews boil down to is they'll give you a LeetCode, HackerRank, or whatever problem thing you want to call it. They'll give you one of those style, for the sake of this, we're just going to call it LeetCode style problems, and basically ask you to come up and implement a solution for that problem. So if you're a sane software engineer, you hate these kinds of problems because if we're being honest, they don't do a very good job of actually testing to see if you know what you're actually doing. And if we're being honest with ourselves, it's really only a matter of time before someone came out and created a tool like this. Because the reason why these problems are so horrible is because it's basically like any academic exercise. In other words, they don't actually prove anything about what you actually know. It just proves how good are you at regurgitating nonsense and making it, giving the illusion that you know something. Because how many times when you were either in grade school or maybe you're in college, did you cram the night before for a test, basically brain dump onto the test, and then as soon as you walk out, you basically forget everything that you quote unquote learned, and then you got a good enough grade that you don't have to worry about it anymore? I would say a decent amount of people put their hand up. And that's basically what these LeetCode problems are, because the thing is once you do enough of them, you notice a pattern in what the problem is trying to gear you towards in regards to what your solution, quote unquote, should be. So these problems are really nothing more than just kind of a pattern recognition exercise of, can you identify what the problem wants you to pick for the solution, and then go ahead and implement that. Now, sure, you kind of have to know some about coding in order to implement these solutions, but if you've done enough of these LeetCode problems, you more than have that kind of a background of, oh, this is a solution where I need to use a hash map or a dictionary, and I need to do this sliding window trick in order to do it optimally. Okay, I can do that. Clack, 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 clack. It's not necessarily a good, test of can you actually think through and reason through these problems, because the issue is if you get, into the interview process with any company that does this technical interview, the recruiter will straight up tell you to practice LeetCode problems in order to prepare for the interview. So they're basically telling you to, practice these problems to kind of gain the what the pre-canned response for these kinds of problems will be. Now, of course, the actual question you'll receive during this technical interview won't be a copy and paste job from LeetCode, but it will be very similar in forms of structure and theoretically how you're supposed to go about solving it. And granted, this is a fairly decent way to weed out people that know nothing about coding. But the problem is just like any sort of test assessment, while yes, you'll weed out, some of the lowest common denominator folks, you're also going to weed out some people that otherwise would be fantastic additions to your team that figured that, they've been coding for, 5-10 years. Surely they can pass a technical interview about how do you know how to write code, and then they get thrown one of these basically, I'm not going to say it's a trick question, but basically, something you kind of sort of have to study and prepare for. You can't just, go in blindly with just your coding wits and know-how and expect to ace it. So you're going to weed out some of those people as well, which in all honesty are probably better hires than some of the people that studied and crammed LeetCode for hours on end preparing for a technical interview. So, but the reason why, the FAANG companies are able to get away with this is because how many people are applying to work for them. It's not like, Joe Schmo software development company where they're trying to hire someone and they might get like 2 or 3 applications, maybe 5 tops. Like if they're trying to throw a technical interview like this, making the applicants do LeetCode problems, they're probably not going to be able to hire anyone anytime soon because people aren't going to put up with it. But people definitely do put up with FAANG's, I guess, kind of shenanigans, if you will, with this whole, LeetCode style interview questions, because the fact of the matter is the FAANG companies have the luxury of being able to do this due to how many applicants are trying to apply on a consistent and daily basis. Because in the software development world, if you're either not in the software development world or you're new and you're not familiar, working for a FAANG company is highly sought after for numerous reasons, and it's basically, in some people's eyes, the epitome of what success looks like as a software developer. To some people, it's basically the definition of you have made it, or you're one of the elite when it comes to software developers in the world, which, in fairness to those people that have that mindset, the acceptance rate for these kind of FAANG companies is very low. If you've applied to a FAANG company, you're probably well aware of this fact, but the success rate is very, very low. It's somewhere in the single digits, some as low as like 1 or 2%, maybe some a little higher, like maybe around 4 or 5%. But the fact of the matter is, there are literally hundreds, if not thousands, of people applying for these jobs, and only a couple % of people are actually getting them. And one of the reasons why working for FAANG companies is so sought after is you don't have to look too hard to figure out that they pay extremely well and their benefits are very, very high compared to other companies. So you can look at there's a site called levels.fyi. and you basically can get a kind of the rundown of what, different levels at these FAANG companies, what their total compensation packages is. And just as kind of an FYI, your eyes might bulge out of your head. And granted, it's not just for those people that work in California, because we all know the cost of living in California is absolutely insane. So, making 100K in California is not the same thing as making 100K in the middle of podunk nowhere. Obviously, making 100K in the middle of podunk nowhere, you're going to be able to keep a lot more of that money than you would, say, living in, LA or San Francisco, but that's neither here nor there. The point is, basically anywhere you work, if you work for a FAANG company, you're basically going to be raking it in, is what I'm trying to get at here. And that's one of the reasons why so many people want to work for these companies, is because of those that pay and those benefits are so, so enticing to those people, that it's worth putting up, with all the shenanigans that they put you through in order to just have a shot at getting a chance to become a part of one of those companies. Because if we're being honest, the compensation packages that they offer is very much a life-changing amount of money, especially if you're a college student and you've really either never worked I'm not going to say a real job, but maybe all the jobs you had up until that point were just kind of like part-time gigs, or maybe you were like a server at a restaurant or something like that. It wasn't like an actual, software development type job. So seeing, and getting all this money, especially maybe if you have student loans or something like that, can absolutely be life-changing. So it's no surprise that people really try to clamor and do whatever they can to get into one of these companies. So it's no secret that software developers are desperate to work for them. And that's kind of where our story resumes, all that preamble out of the way. So this now former Columbia University student wrote this tool to basically interview for FAANG companies to ace the coding interviews. So according to this student, they claim to have received offers from the likes of TikTok, Meta, Capital One, and Amazon. And they actually happened to record the entire Amazon interview process and published it on YouTube, which my understanding is that video has since been taken down, but I'm sure if you look hard enough, you'll probably be able to find copies of it floating around somewhere if you look hard enough. But once it got out that he cheated, basically all the companies rescinded their offers. Now, I do believe he did reject some of the offers before the word kind of got out that he cheated, since for him the point wasn't to work for one of these companies, but just to kind of show how broken the interview process and how easily it can be cheated or cheesed, I guess. But the problem with this is he's basically got himself on a block list for basically any FAANG type company. No one's going to want to touch him with a 10-foot pole because they know that he's cheated in the past and there's probably a decent chance he'll cheat in the future. And it's basically, if you do think that you want to use this interview coder to try to ace a technical interview, you're basically just asking for problems, because if they do find out that you're using some unauthorized piece of software to basically cheat on the interview, like with this guy, you're going to end up on a block list somewhere, and it's basically going to be impossible for you to get a job at any kind of big tech company, because you can almost bet that the recruiters are passing around information and they're sharing details about people that they have on their block lists for like, hey, don't hire this guy. So yeah, don't be trying to cheat on your technical interviews. But let's say that you don't get found out. Let's say you used Interview Coder and you cheated on your technical interview, and congratulations, you got an offer from a FAANG company and you started working there. The problem is, it doesn't mean that you can just sit there and chill and watch the money come in, because they'll expect results from you. And if you can't deliver on those results, well, guess what? There are hundreds, if not thousands, of software developers more than willing, ready, and able to take your job from you. So just because you have a job at a FAANG company doesn't mean that you're safe and you can basically just coast. If you don't know what you're doing, it's going to become evident pretty quickly that you don't know what you're doing, and you're going to get canned. So, but the thing is, FAANG is also taking notice of this. They realize that some kid pwned them and basically made them look like fools. So they're taking notice now. So while a tool, and they're basically going to be modifying how they do their technical interviews to basically better weed out cheaters. There's a couple different ways that they're basically going to be trying to implement this. One, if you're not aware, a lot of these FAANG type companies are trying to get their developers back in the office, and basically their entire workforce back in the office. But as kind of a counter, or not counter, but in addition to that, because everyone's coming back into the office, one fantastic way to wean out cheaters is to make you come into the office for the interview itself. So it's easy to cheat if you're behind a screen and you can use some kind of AI software to do screen grabs and stuff, even if they're trying to use a tool that can detect things like that. That's nothing a little virtual machine goodness can't get around. But if you're actually physically in person with the interviewer, you really can't get away with that. It would be very obvious very quickly if you were cheating. So that's just one of the ways that they could potentially try to stop cheaters. Another one is basically ask you questions about what you're doing, more detailed questions about what you're doing. Because one thing that is very noticeable very quickly about someone that is just regurgitating their answer verbatim is they don't have any good reason for the what or the why of why they're doing things. They don't think about alternatives, and this is also very evident, like if you're trying to cram before a test. You're not thinking about why this is the right answer. You just know this is the right answer, so that's why you picked it. You're not, thinking critically about why this is actually the right answer. So when it comes to the coding interview, one thing that the interviewers might do to you is if you're just, click-clacking away, explaining the code as you type it and going through, they're like, okay, well, can you think of any other ways that might work? Or can you think of any other implementations that might work? And if you're just like, I don't know, I mean, this one works, they're probably going to be a little skeptical. Even if they're not skeptical that you're maybe cheating, they're going to be like, well, this guy might not necessarily have the best idea to think of possible alternatives. Because one of the big things in software development, I've touched on this before on the podcast, is one of the biggest core pieces of being a successful software developer isn't just that you know how to write code. It's that you can think through problems and problem solve. Problem solving is probably like at least 80% of the job, because sure, if you know how to write code, that's obviously something you need, but being able to write code is basically worthless if you don't know what you want the code to do or how to use the code in a way to solve the problem you're trying to solve. So one of the ways that interviewers could potentially try to wean out cheaters in this sense is to see what your problem-solving ability is actually like. Okay, cool, you got this solution that I was looking for, but what are other solutions? Because basically, if you've ever written software before, you'll find out very quickly that there are tons of different ways to attack the exact same problem and get the same answer. Sure, some are more optimized than others, but there are without a doubt a numerous number of ways that you can, solve the same problem, different approaches you can take, different data structures you can use, different algorithms you can use. There are tons of different ways to solve these problems. So being able to demonstrate that you can think through the different possibilities is something that the interviewers are absolutely going to be looking for. But it's also not specifically just for cheaters too, because it's also a red flag for someone that just kind of memorized leet code solutions. If they just kind of regurgitate the answer and just kind of be like, yep, this is it. So it's not necessarily a guarantee that they were cheating, but also that they might have just kind of crammed memorized leet code problems. But I guess the silver lining to this is if you aren't someone that, wants to cram and memorize leet code problems, because if you don't, I honestly don't blame you. But the good thing is if you can think critically about the problem and, vocalize, what your thought process is, what you're thinking about, the alternatives you're thinking about, different ways that you can test to make sure your solution works. All these things prove to the interviewer that you're actually trying to work through the problem and trying to, fully internalize, understand, and come to a solution rather than just regurgitating something. Because as good as it is to come up with the quote-unquote right solution, if it's just a complete black box and you don't know how you got to that solution, that's basically just what AI is in the first place, right? It's basically just a black box. You don't know what its thought process was of how it got to the solution. It just got to the solution. So if you're wanting to really understand if someone knows their stuff, you want to kind of see that thought process in action. So the good news is even if you don't cram memorize leet code problems, if you can at least, walk through what you're thinking about, asking questions, thinking about test cases, and kind of walking through solutions. If you hit a roadblock, be like, wait, no, this won't work because XYZ, so I'm going to try to rework it and do it this way. That shows the interviewer that you're actually thinking through the problem and trying to come to a solution, and basically kind of shows your problem solving abilities rather than just, can you get the answer right? Because at the end of the day, with one of the parts of these technical interviews is, sure, do you know how to code, but also can you work through these problems to come up with a solution? So basically, to summarize here, cheating on interviews is a lot like cheating in school. The best case scenario is you get through it, you learn nothing, and your chance of success is very low. In this case, your chance of success at the company is very low. But the worst case scenario is you get caught and you get put on a blacklist and companies basically avoid you. So let this be a lesson to you out there that you should not be cheating on your technical interviews, because FAANG got pwned once and they're definitely taking notice and they're not going to let it happen again. So that's the first thing I wanted to touch on. The second one is this phenomenon called vibe coding, which I don't even know where we should begin with this one. I don't know where these names for things like this come from. It's probably some like TikTok shenanigan garbage. But basically the TLDR for what vibe coding is imagine an entire application written by non-software developers that's held together with chewing gum and toothpicks and has more spaghetti than an Italian restaurant. That's basically what vibe coding is in a nutshell. So, in other words, it's basically garbage applications that are so horribly implemented, it's impossible for anyone or literally anything to understand how anything works, track down bugs, or add features. Because what happens is people are basically prompting AI, because AI has, let me do the proper term. The Gen AI has progressed enough to the point where individuals have got the bright idea to basically ask AI to write applications for them. And then when the code inevitably doesn't work, because it usually doesn't, they'll basically ask the AI to fix the code and basically rinse and repeat until they have a product that's at least semi-functional enough that they can ship it out the door, charge money for it, and basically call it a day, make a quick buck on basically zero effort. And I don't even know what to think about this. I mean, if you've ever used any kind of AI to do coding for you, now granted, it's become a little bit better, but there are still so many instances where you ask it to do something for you, and unless it's a very, very trivial task, it's probably not going to work. And that's assuming it even compiles, if we're being honest, because I can't tell you how many times I've seen an AI like completely make up a function name and it just doesn't exist. It just hallucinated the function into existence. And the problem here is because everything's generated by the AI, you get to the point where the project becomes so large that the AI can't even keep track of it all, and it just becomes a completely unmaintainable mess. And let us be very clear about something here. If you think vibe coding and generating these projects with AI is going to help you get a job, it won't. Now, unless the entire point of the job you're trying to get is some kind of like prompt engineer, I mean, I guess that's a different story. But if you're trying to vibe code to get a software development job, sure, it'll impress on a resume and might get you an interview. But the second the interviewer asks you about the project and you basically have absolutely nothing, that's where you know what's going to hit the fan and your interview is going to go to you know where in a handbasket, because it's going to become very obvious very quickly that you have absolutely no idea what you're doing or how to write code. Because granted, like I said, if the whole point of this is you're trying to get some kind of like prompt engineer job or whatever, then that's a completely different story. But the one of the best ways that I've always said that you can set yourself apart from others is to work on personal software development projects in your free time. But the important distinction there is that you work on software development projects in your free time, not an AI. So, because the problem here is if you put on your resume that you did XYZ project, and you kind of list off all the features that it had, if an interviewer sees that, they're going to ask you to tell them more about it. They'll be like, so what was your thought process going in? What kind of, data structures did you use? What algorithms did you use? What kind of challenges did you have to overcome? And if you just had an AI do it all, you're not going to be able to answer any of those questions effectively. And it's going to become very obvious that you didn't actually write that code yourself. So yeah, that's one thing. But the other thing is the whole point of personal projects, at least in my opinion, is one, for you to have fun, but also to learn and to just hone your skills as a software developer. And the value is basically lost if all you're doing is asking a chatbot to do something for you and then telling it to fix the thing that it didn't do right the first time or the second time or the third time, or maybe even the 20th time. Who knows? Because these chatbots can sometimes continue to get things wrong, and So basically, I'm not trying to say that you shouldn't use AI when developing software, since like Stack Overflow, if you use it effectively, it can significantly speed up your development process and get you, where you want to be significantly quicker. However, if you're exclusively using AI to write the code for you, you're not gaining or learning anything. You're basically just using it as a crutch in order to get by. So for instance, if using an AI to, say, write monotonous things like getter and setter functions, or maybe writing documentation for a function, that's one thing. But the problem is if you're asking these AI models to do significantly more than that or do more complex things, that's where they really start to fall apart, because these AI models can only contain so much context within their memory space in order to generate, the solution. Because the other thing you also have to keep in mind with these general AI things is they're basically just math algorithms that are predicting the most likely thing to come next, which is how they hallucinate nonsense, because they're like, oh yeah, this makes the most sense. You want to call this function because that's what we're trying to do. But yeah, but that function doesn't actually exist in the API. And that's kind of where things fall apart. So the more amount of code you ask it to generate, the more likely you're going to hit one or multiple instances of this happening. And if you don't know how to actually debug the code, you're basically just going to get in this endless loop of asking the AI to debug it for you, and it just adding more bugs and not fixing things, and it's just going to become a mess. So the other thing too is because, the larger and larger your AI generated code base gets, the less and less effective the AI will be at keeping track of everything and keeping track of all the spaghetti that it's cooked up, since, like we mentioned, it only can hold so much context. So if you haven't had any part in this spaghetti making process, you're going to have absolutely no idea how to track down bugs, where to look for things, that aren't working, where to add features, or any of that. Whereas in contrast, if you're the one that actually wrote all the code and maybe used AI to help debug something, or maybe used it to write, some getter or setter functions, or maybe had it write some documentation for you, it's a lot easier to track down bugs and fix problems in that case, as well as to continue to build upon your existing code base, since you know where everything is. And there's a reason why these gray-bearded wizards that write code can tell you exactly where everything is in the code base. It's not because they're using some AI to tell them. It's because they have either written that code or they have used those functions so much they know exactly where things are because of how in tune they are with the code base. So if you just have an AI to generate this spaghetti code base for you, you're going to have absolutely no idea where anything is. So as an analogy to take this away from coding for a second, because I feel like I've probably lost all of the people that aren't, in tuned with software development and kind of this programming mindset. So for all of you that aren't software developers and aren't programmers at all, come back for a second, because I'm going to try to make an analogy that will hopefully make sense to you with what I've been talking about for the past 10, 15 minutes. So imagine you're moving into a new place and you didn't take the time to unpack any of your stuff, and you had someone else, whether it was the moving company or you hired someone, to basically unpack everything for you and put things in homes for you. Well, guess what? When you're not going to have the slightest clue to where to look for anything or have any idea where anything is in your house because someone else did it for you. It's like when you go to someone else's house and you're trying to cook in their kitchen. You have no idea where the pots and pans are. You have no idea where the utensils are. You don't know where the spatula is. You have no idea where the measuring cups or measuring spoons are. You don't know where anything is because you weren't the one that put it there. So it's the same thing with these code bases. Just like you in a kitchen you've never been into, trying to fumble your way around and figure out where things are because you quite frankly have no idea, it's the same thing if you have an AI completely generate your code base for you. You have no idea where anything is. It's going to be an absolute nightmare to track down bugs and fix things. You're not going to know where things are put and organized, so it's going to be hard to build upon and add new features, which is why these vibe coding projects get to the point where they're just functional enough to ship, because usually once they get to the point where they're just functional enough to ship, that's basically when the AI has basically become unusable and can't even manage its own code base anymore. Now, if you've looked, I do encourage you to kind of look at, some of the examples of like vibe coding projects. I think one of the most famous ones right now is some kind of like flight simulator thing. If you've actually seen that project, it doesn't look impressive at all, and it's honestly kind of a mess and pretty terrible as far as the frame rates and everything are concerned. But it apparently was decent enough to make money on, and that's basically the whole point of it. So yeah, hopefully that kind of helped you non-software developers kind of understand, what we're kind of talking about, this whole vibe coding type thing. So just to kind of summarize here, that whole idea of being in a kitchen you've never been into and been in before and trying to cook something, how you basically spend a ton of time just fumbling around trying to find things rather than actually cooking something, is basically what happens with these software development projects that are generated by AI. If you're the one that actually wrote the code and you're more in tune with the code base, it's going to be a lot easier to track down bugs, build new features, and figure out and understand what functions, what classes are in which files, etc., things like that. And in turn, you'll know exactly what you want to reference for new implementations and where to build on and expand from that. So just like if we take this back to the kitchen example, if you're the one that organized your own kitchen, you know exactly where everything is. So if you want to add some spices to whatever you're making, you know exactly where the spice cabinet is. If you need to grab a spatula, you need to grab a spoon, you know exactly what drawer those are in. If you need to grab an extra pot or pan to boil some water, you know exactly where that is. You can get that out real quick and start cooking and get going. Same thing with software development, right? If you know where everything is, you actually wrote the code yourself, you're going to be a lot more in tune with it, and you're going to be able to understand where things are, how to track things down, how to debug it more effectively, and you're just going to become a better developer rather than trying to just ask an AI to do everything for you. Because at the end of the day, if you're asking an AI to write all your code for you, you're not actually learning anything. Because like we said, if that is your entire portfolio is just AI generated garbage, good luck trying to get a job with that, because it's going to become very evident very quickly that you don't actually know how to write code. And when your AI tool is pulled away from you, you're basically kind of useless. So that was a lot of ranting and hating on artificial intelligence use cases. And I think what it kind of boils down to is these tools can be useful, but they shouldn't be your entire reason for existing, if that makes sense. So, in essence, you should be able to write code and develop without the use of an AI assistant or chatbot or whatever. Just like you should be able to write code yourself without having to copy and paste endlessly from Stack Overflow. The basic stuff you should be able to do. Now, that's not to say you shouldn't, be able to code everything without ever having to look at, documentation for the programming language or docs in general, because that is completely unrealistic. Even if you've been coding for, decades, if you encounter a new framework, a new API, or you come back to a, function or class or something you haven't used in a few years or maybe even a few months, you're probably going to have to look up and refresh your memory about how it actually works. But that's significantly different than encountering something that you're not entirely sure how to go about solving and immediately turning to Stack Overflow or immediately turning to an AI to solve your problems for you. Because like we said at the beginning of this episode, and I've said consistently throughout this podcast, one of the most important fundamental core pieces of being a software developer is your ability to problem solve, even more so than your ability to actually write code. If you can problem solve, you'll be an effective software developer, because the coding language is basically agnostic. Once you know how to code in one language, it is very easy to pick up another one. It's just that initial, how do things work in code? How do you write for loops? How do you work with data structures? How do you store, information in memory? Things like this. Once you understand kind of the basic concepts, it's basically just a matter of, okay, how do I do that in this language? And you can easily find that online or in a textbook or wherever. But the core idea of figuring out how to problem solve and figure out the solution in the first place is something that sets apart the mid or okay software developers from the elite software developers. So I think that's probably where I'm going to leave it. I could probably continue to ramble on and rant, but I think I've gone on long enough at this point. So let's finish up with our trivia question for the week. So the IEEE 802.11 is a family of standards that make up Wi-Fi, the first iteration of which had a max blistering speed of 2 megabits per second and was released in what year? If you said 1997, congratulations, you got this week's trivia question correct. So I guess if you're of the younger generation and you hear someone that grew up in the 90s complaining about, how good we have it with internet speeds, I guess you can tell them that, what are you talking about? You had Wi-Fi back in the 90s. Don't whine and complain to me, Grandpa. But yeah, so came out in 97. Of course, 2 megabits per second isn't setting the world on fire, but compared to dial-up, 2 megabits per second is pretty dang fast. So that is going to do it for this episode. So if you enjoyed, definitely be sure to leave it a rating and review and subscribe if you haven't done so already. And also be sure to share with any friends or family members or anyone that you know that's a software developer. If you have any questions about this episode or have any topics or ideas for future episodes, if you're on YouTube, you can leave a comment down below, or you can always shoot me an email at contact@darkassassinsinc.com. There's a link for that down in the show notes below, like always. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.